In my earlier video covering the Heathkit IB-1103 Frequency Counter, I went on at some length about the issues that are inherent to this model regarding a bad decision by Heathkit engineers in relying on a piece of paper to insulate a metal bracket that was laying on top of a circuit board's foils in order to prevent shorting those foils, and how that paper fails and short circuits happen. And luckily, the main impact that they have when that happens is it messes up the way the decimal points work. And it would be a very difficult fix if it's practical to fix at all. So I had thought sort of out loud in the other video about maybe some sort of a little external chart or something could be used to show the user where the decimal point should be for a given combination of push button switches, and then they can just follow that and not worry about where the decimal point should or shouldn't be. So I created this PDF. It's a one-sheet document. It explains the issue, it explains why it's difficult to fix, it describes what is provided on the middle of the sheet in the form of a card or a chart on a card, which can be cut out and either put on the meter somewhere, like on the top of it or the back panel or whatever, or just kept loose, on the table next to where the thing is being used. And there's also a small label on there which optionally can be cut out and stuck onto the bezel right below the display, and that goes along with the card. Here's a picture of one of my IB-1103s, the one that was featured in the video, and it just shows where I stuck the card on, not especially centered, but just near the front, and it's with removable adhesive so it can be peeled off easily, like a post-it note, and put somewhere else. And I printed it on one of the laser printable no-tear papers which are out there on the market, and that way it won't get weird by absorbing moisture or something, and it'll stay in the same good condition. And if it's not stuck on the meter and just kept on the desk or the table near where the counter is, then it wouldn't get banged up from handling. Here's what the label looks like. The time base and multiplier columns are phrased the same way and in the same positions relative to each other that the buttons are on the front of the counter. And the nomenclature is the same, so 1 millisecond with sec spelled out and so on. And then the X1, X10, X100, X1000 for the multiplier. And then as a courtesy, it confirms which of the range lamps should be on, whether it's hertz or kilohertz or megahertz. And then on the right column, it shows which decimal point should be on. And this is what the label looks like. It's just a skinny label. From top to bottom, it's the same dimension as the angled edge of the bezel right below the display window. And the little tick marks align with the spacing of the decimal points on each of the 5 least significant Nixie tubes. And then the numbers correspond to the right-hand column in the chart. So if the chart says DP position 3 should be on, then you just glance at this label and expect that there should be a decimal point right above the tick mark, whether there is or isn't, and whether there are other decimal points that might be on erroneously. It just lets you have a visual guide to this is where you have to imagine the decimal point being. Here's a photo of my IB-1103 with the label in place on the lower bezel edge and the tick marks aligning with the decimal point positions, and you can see that there are 2 decimal points that are on there, and if one looks at the chart, you can just say, well, the one above tick mark 3 should be on and the other one shouldn't. And that lets you at least take reasonable readings of unknown frequencies using the counter, even with the malfunction going on.